Good morning students. Hope you are all well at home. I am Ranjeet sir and I will be conducting your physics classes today onwards. Students, your first term syllabus is chapter number 1, that is matter. Chapter number 2, that is physical quantities. And measurement. So these are two chapters which are there for the first term. So today we shall start with the first chapter, that is matter. In previous classes you have studied both the matters. There are many possible definitions of matter. In science, matter is the term for any type of material, or matter is anything which has mass and occupies space, like substances, that has mass and volume are known as matter. So just see that matter is consist of two quantities, one is mass, another is volume. So by knowing the mass and volume of the matter, we can calculate the density of the substances, like density is equal to mass per unit volume. In physics, density is represented with Greek letter, that is rho, and mass is represented with letter m and volume v. Now here we can derive the SI unit of the density. As we know that the SI unit of mass is kg and the volume is meter cube. So it can be written like this, kg per meter cube. So this is the density of the matter. Now students, some of the example of the matters. Examples of matter, like proton, atoms, molecules, compound, cat, tree, computer. Okay students, so there are few examples of matter. So all these matter has mass and volume. So now the question is, if all these are the matters, then what are the non-matters? Non-matters substances that has neither mass or volume. That is called non-matters. Now, some of the examples of the non-matters. Photon. These are the energy packets which are there in the light. Then heat, and then microwaves. So students, there are so many examples. Now I have given only three, that is photon, heat and microwaves. It means that these are the non-matter. These do not have mass and volume. So now we can differentiate between the matters and non-matters. Now let us move to the next topic, that is states of matter. States of matter. Matters are made up of tiny particles, namely atoms and molecules. So all the matter can be divided in three main groups on the basis of physical states as solid, like some of the examples: rock, wood, brick, then liquid like water, milk, petrol, then gas, that is air, hydrogen, and nitrogen. Okay students, so matter that can be divided into three states, that is in solid states like rock, wood, brick, liquid state that is water, milk, petrol, then gas states that is air, hydrogen and nitrogen. Now all these groups can be differentiated with the help of their characteristics. There are two main factors which influence the state of all matter. Once again, there are two main factors which influence the state of all matters. The first factor is, that is constant motion of the particles, namely atoms, molecules and ions. And the second factor is, that is the particle force of attraction. Force of attraction called force of cohesion. Between the particles of the matter. So students, these are the two factors which are responsible or which influence the state of all matters. Now student, you must be thinking about this force of cohesion. So let me explain it. Look students, I am having a glass of water in my hand. Now the force of attraction between the molecules of the water. Once again, the force of attraction between the molecules of the water, that is known as force of cohesion. This is between the molecules of the same substance, that is water. So what is the force of cohesion? It is the force of attraction between the molecules of the same substance, that is water, like here. Now there is also another force, that is a force of adhesion. Now it is the force between the molecules of the two different substances, that is water and glass. Like here the water is poured in the glass, so the force of attraction between the molecules of the water and the glass, that is known as force of adhesion. So students, there are two type force, don't forget. One is force of cohesion, another is force of adhesion. Now move to the next. Now this attractive force influence the state of all matters. Like if the body is in solid state, like the molecules of the solid state body you see that the molecules of the solid body are very tightly packed. The interspacing between the molecules is very less. Or in other words, you can say that the intermolecular force of attraction between the molecules of the solid is very large. And whereas in liquid, you see that the interspacing between the molecules is more than the solids. Or in other words, you can say that the intermolecular force of attraction between the molecules of the liquid is less as compared to solids. Then move to gas. You see that the interspacing of between the molecules is very large as compared to solid and liquids. In other words, you can say that the intermolecular force of attraction between the molecules of gas is very less. So students, if the body is found in solid states or liquid states or gaseous states, that is all due to the interspacing between the molecules of the matters. Now, in solid states, let us discuss some physical properties of solid, liquid and gases. Just see that the moment of particles, that is very less in solids. The reason being is that they are very tightly packed. The molecules of the solid vibrate what they vibrate about their mean position. And in other words, we can say the moment of particle is very less. But in the case of liquid, the interparticle attractive force are bigger than that in solids, but they are capable of keeping the particles not far from each others. Or in other words, we can say that the moment of the particles or the vibration of the particle is much more than the molecules of the solids. Then move to the gaseous states. The intermolecular force of attraction is very less. So in other words, we can say that the vibration of the molecules of the gas is very high. Now students, solids like, for example, this duster is in solid state and having a definite shape. And whereas a glass of water is with me, now water is poured in the glass and just see that this liquid does not have a definite shape. So let us perform one activity in order to prove that liquids do not have a definite shape. So students, I am having 3 containers with me. Like one container is this, another is this, another is this. Now I am going to pour a water in it. Now you will see that the water has taken the shape of the container in which it is poured. So we can say that the water do not have a definite shape. So student, that's all for today. Thank you very much.